This question is from the 2016 higher level DCG paper and it's question B2. It's based on conic sections. The image on the right shows a hotel located beside the River Shannon in Limerick. Two views of an architectural model of a similar structure are shown in the 3D graphics below. The outline projections of the structure are given in figure B2, which is this one down here at the bottom. The plan is based on an ellipse reflecting the city's rugby tradition. The top of the structure is parabolic, as indicated by the curve ABC in the elevation. B is the vertex of the parabola, up here at the top. One side of the structure has been shaped to produce a flat vertical surface as shown, so one side is cut off. Part A, draw the given plan and elevation of the structure. Okay, we'll begin with that to start off. Its scale 1 is to 100. There isn't much to the plan view there. I need to leave 90 from the bottom. 90, I'll just leave 100 there. Okay, XY line across the page. Y, so I'll start off with my front elevation. The full width is 10, which is 100. Start off with the center axis. And 100 millimeters. Full height is 14. That's not the full height, that's just up. Oh, sorry, 14 is up to the, yeah, 14. It's 140 millimeters. Make sure I have room here, then I need 40 millimeters on top. Okay, it's going to be tight enough for space, but it should work. Now, up at the very top, I have my parabola. The height is 4 meters. So that'll be the vertex up there at the top. I'm going to use the rectangle method. It's probably the more straightforward method for this. Okay, so I'm going to divide up the side here into 5 equal spaces. So it's 50, it's quite easy to divide. Side here, I'll 5 equal spaces as well, so I'll do the equal divisional line. So I'll draw a line at any angle, set my compass to whatever distance, doesn't matter, once it stays the same, and plot 5 different lines. Then I'm going to join the last point on the line to the end of the line I want to divide. Which is that one, and use my sliding set squares then to divide up the line into 5 equal spaces. Okay, the lines at the bottom go vertical up to the top. And then the ones at the side join to the vertex there at the very top. That gives me points now on the parabola up to the top there, and I can just join them to finish it off. That's one side finished. I'm told that the cut on the right hand side comes in 2 meters, which is 20 centimeters. So I'll draw that up to the top so that I don't draw any of the parabola that I don't need. So that's the cut surface there at the top. I'm going to mirror across now the different points on the parabola to say I've drawn the construction again. Points mirrored across, so that's the first distance there. second one. Third one just brings me to the end, so I don't need to do the last one. And that does that shape. Okay, I'll draw a heavy line then going down the side, and that will be my front elevation finished. Now, I'm going to move on to the end view, or the plan view now next. So I'm told the distance down is 15 millimeters. And the full minor circle is 6. So I'm going to measure down 3 and draw my axis going across. And the full major axis will be the same as front elevation there. Okay, so compass there, set it to the radius of the major axis and draw in the circle. Keep it light because it's only construction. Then set it to the minor axis and draw in that circle as well. Divide up my circle now, 30/60 set square, 12 equal spaces. And then same method as usual for an ellipse. From the major axis you come down, the minor axis you come across. Now, it only goes to this point, so I don't need to draw any more beyond that. And then I'll have my heavy line there in plan. And that's my plan view complete as well. Now, part B asks, project an end view in the direction of arrow E. Now, arrow E points in there from the left, so our end view is going to be on the right hand side. So I'll start off by bringing up, I'll take this as the edge point here. And I'll bring up my center axis there and draw in my center axis for the end elevation. Full width of the end elevation will be the full width of the minor axis there in plan view. Bring up the two sides. .45 degrees and bring them straight up in the end view. Okay, once I've brought those up, they're going to go up the whole way to the top. So I'll just draw this across the top here. That's my basic shape. Okay, so it all has to fit inside that now. Now, we're going to have to take a series of cuts here to see this shape where this parabola slopes down here on the top. So I can bring the lines that I have already there. So I know it starts at that point. That's going to be the starting point where it slopes. And I can bring across the lines that I already have to save drawing more cut lines. So I'm going to take a series of horizontal cuts here. To get the positions now, or the exact points in the end view, I need to drop them down to the plan. So the whole way down to plan view, I'm going to do the full loop now and bring them back up to the end view. That will give me the exact widths of each one of the cuts then in the end elevation. So that's one of them. 2, they're quite close together here. 3 and 4. Now if I do one side, I can just mirror them across because both are going to be the same. And that one's just in the middle. Okay, and then I'm going to bring them up to the end view. Now, I need to figure out what way this goes in the end view. So it's going to start on the outside point there, and it's going to slope its way back in till it gets to the point down here at the bottom. So that curve there at the top, because if we do the loop, say that one there for example, I go down, across, back up and over. It creates a full loop on the drawing there. To get on the other side then, I'm just going to mirror those points across. I could bring them from the plan view. It's probably a little bit quicker and there'll be less drawing to do if I mirror them. The last one goes up to the top there. Okay, so that's my shape then on the left hand side. The top of the object will be flat, going across, and the two sides going down will be heavy. Okay, that'll be my end view finished. Last part then, part C, an architectural feature in the form of a steel band, which you can see there in red, is to be constructed around the outside of the structure as shown in the 3D graphics. VT, which is here at front elevation, and HT are the traces of an inclined, sorry, let's move it up, of an inclined, where am I there? Traces of an inclined cutting plane used to define the position and shape of the steel band. Determine the true shape of the intersection between the structure and its inclined cutting plane. So if it's cut by this plane, they want you to figure out what the true shape of the cut surface would be. Okay, so we need to draw in those traces to begin with. So they say it's up 120 millimeters. 120 would be that point there. Just going to draw that line across. That's VT. And then HT is way down in the very bottom. That's 90 millimeters from the XY line. Now you can just about see that. I'll just move the camera down there a little bit. And that is HT. Now, looking for the true shape. So the best way to do this would be to draw it in the end elevation so that we see it as a line view. It's best to see it as an edge view to get the true shape of it then. So bring up the line HT to the XY line. So I know it hits the ground at that point. Bring the line VT across there till it hits this, so it hits the back wall at that point. So if I join the two now, that's the plane cutting through the object. That's the shape there that you'd see. So to get the true shape now, we just need to look in with an auxiliary view looking in perpendicular to it. So same as usual for your auxiliary views, you're going to bring your line out. No room if I do this one. X1, Y1, line parallel to it there. It's going to go slightly off the page here, so it's going to overlap, but you wouldn't lose any marks for that. It's quite restricted for space, so I'm just going to do my X1, Y1 line there. The center point will be this one, so I'm going to bring that out there to the side, just make sure it's perpendicular. So center point goes out there. Top point is going to cut out at that point and that point there. Okay. Next point then, we need to find the center point. So I'm just going to draw an axis. So the usual would be previous XY line back. So I'm going to say here down to plan. So that'll be to the center point there. So I'm just going to measure out to the center point there for that one. Let me just think now, because we're working from the side there. Doesn't really matter there what distance we come out. So we'll come out to about that point. It's just the true shape that we're looking for here. So say that's my axis. Now, the distance on each side there, if I measure them, is about 50 on each side. And if we go back to the other one here, it was 50 on each side as well. So at the minute, this tilt is showing that if it was cut, it's 50 up here and here. The distance out on each side as well is going to be 50 and 50. So technically we get a perfect circle here when we cut at that angle. So it's not going to be an elliptical shape or anything like that. It's going to give us a perfect circular shape. It should just touch the top and bottom when drawn in. So that would be the cut shape there. And then there would be one flat edge. So to get the distance for the flat edge, we can measure it in from the end. So from the center point out to the flat edge will be that distance there. That'll be the true distance out. So if we measure that true distance out on the side there like that, draw a parallel line to the center axis. That'll give the flat edge there at the bottom. And that shape then the whole way around would be the true shape of that cut surface when the object is cut by that plane. Now a different way to get that, we could also bring it up. We could draw the cut surface on the back. Technically I suppose that should be there too. So the cut surface would be in hidden detail. It'll be brought across from there and it's cut straight across like that. And to go down the two sides there as well. Just see do the two line up at the end. So that'll be the cut surface at the back of the end elevation, just to get full marks. And technically, when we bring these out, that's the cut surface there. Should line up with the line I'm after drawing there before. So it should line up with that point and that point. So that would be more accurate than bringing it from plan view there. Those 2 points then give me the cut surface. Okay, I'm going to rub out that one, leave that one to one side, and that's your question finished.